Unit 3, Lesson 4A. Again, I'm calling them 4A for application. We have 5 lessons of application this unit, so that's what makes this up to 13 lessons. This is number 12, so we're almost there. So, introduction. So just in general, we got to still make sure we can do our switch the case. So if log base b of p equals log base b of q, then we can say that p equals q. So we want to use that to our advantage, getting stuff with the same base. So they have the same base, and we can set their insides equal to each other. And we'll use that when we have a variable potentially in the inside. Okay, I'll show you what we're going to do down here in a second. The other thing, too, log base b of p equals q. We know we can write that exponentially as p equals b to the q. Okay, that's our normal log to exponent switch. This right here, okay, just being very direct, if you still can't do this or this still seems foreign to you, you need to get it fixed. You need to ask me how to do it. You need to make sure that we're talking about why that's not making sense to you, because the exponential to log and log exponential needs to be automatic. Okay? This part here, it just makes sense. I think you'll see when we do the solving, it just makes sense. Okay? All right. Exploration. Okay, so Alice is solving the equation. Log base 5 of x plus 1 plus log base 5 of x minus 3 equals 1. Part of her solution, including explanation, is shown below. So she did use the product law. Put those together. Okay. Then she said, well, x plus 1, x minus 3 equals 5 to the 1. So she converted to exponential. So you can kind of see how knowing your rules and switching to exponential can help you navigate through a solving. So things that they did. Use the product law, wrote as one log. Remember, writing as one log is helpful because then what? It's easier to convert to exponential. Because now you have one log. So it's just 5 to the base of 1. That's why that's there. Okay, equals this here. Okay, that's your exponential switch. So now we're good to go. Now we can just solve. So how do we solve this? Well, we'd FOIL this out because it's a quadratic, and we'd get one side equal to 0. So that's what we're going to do next. Is everybody okay with that? So this is going to be, this is going to be x squared. Okay, x squared, negative 3x, and 1x is a negative 2x. 1 and negative 3 is a negative 3, equals 5. X squared minus 2x minus 3. If you can't FOIL that fast, that's not a problem. Just for the sake of video, I'm doing that part fast. I'm assuming everybody can FOIL. Okay, minus the 5. X squared minus 2x minus 8. So now we're going to see, can we factor? If we can, we'll be able to get our solutions pretty easy. If we can't factor, does that mean it's not possible? No, what's that mean? Quadratic formula, yeah. Discriminant will tell you how many solutions, but not the solution. Quadratic formula will give you a solution. Okay, so we would use quadratic formula in that case if you can't factor. This one does factor. X minus 4, x plus 2. So that means my solutions are 4 and negative 2. Okay, we still have to check this because of the logarithms, right? Because there's some restrictions with the logarithms. We need to make sure we're okay. Okay, so if we check it, let's look here. Let's put 4 in first. 4 plus 1 is 5. So that would be, let's just do it right here. So log 5 of 5 plus log of 4 minus 3 is 1. So that's log 5 of 1 equals 1. Now, who can explain this to me real quick of why that's correct? Do you see it? Okay, so let's just do this together. What's log 5 of 5 equal? What's log 5 of 1 equal? 0. Any log to 1 has to be 0, remember? Because this is saying 5 to what power is 1? 0. So this is 0, this is 1. We're good. Okay? So we should know this one. When stuff cancels, that means it's 1, not gone, right? So this one we know is 1. And remember, log of anything of a 1 is 0 every time. Has to be, because everything to the 0 power is 1. Okay? So 5 to the 0 power, that'd be this. Okay, here. If you're not seeing it, look. Right? That's what we just said. 5 to the 0 power is 1. 5 to the 1 is 5. Okay? Those are kind of the automatics. Okay? So that one's good. Let's look at negative 2. Log 5, so that's going to give me log 5 of negative 1. and log 5 of negative 5. So what's the problem here? 5 to what power is going to give me negative 1? It's not possible. Remember, we can't have negatives there because the output of an exponent won't be negative. Now, if you think, well, we can have negative exponents, yeah, we can. But that's the equals, not this number. This number can't be negative because nothing outputted will be a negative number from a base of 5. Okay, does that make sense? Okay, so these just aren't possible, so this one we can't do. So negative 2 is not a solution, 4 is. Okay. And so we just did that, and let's see here. It says circle the correct alternative. In solving this equation, Alice arrived at one or two positions shown in the introduction. The position Alice arrived at, she arrived at this one. Log base b equals q. So she converted to exponential. So the two ones we're looking at is log same base, and then when we can go log base to a number, we can convert to exponential. All right, let's get to some examples here. All right, so when attempting to verify the solution x negative 2, the previous example, we reached the situation of the logarithm have a negative number. We know that logs expressed are only defined for positive values of the argument. Remember, argument's that number we pointed to. So negative 2 is that extraneous solution. You remember math 20. Extraneous is a solution you get that doesn't work for the given constraints of the problem. Okay. All right, so let's go ahead and just get to this here. Let's just get some examples going. Solve the following log equations. So log x squared equals log 16. So what are their bases? 10, right? Nothing's there, so it's a 10. So they have the same base, so we're good to go. X squared equals 16. So x equals plus or minus 4. Yeah, we got to do plus or minus, and we have to check. Okay. And when you plug in plus or minus 4, it works for both, right? Because the x squared makes that positive. So both answers work. Okay, I don't really need to plug those in. Is that okay? 4 squared 16, negative 4 squared 16. So it's going to be okay either way. And so the reason they put this one here is, so what's the problem with this one? Yeah, it's got the 2 in the front, so I can't say x equals 16 because of that 2, right? So we want to use our exponent rules. We want stuff to be all in the log. We can push that up, right? So it's the same problem. And so we just know it's just the same thing we just did here. So push that exponent up if you need to. So you have the one log to get log equals log. But when you do it this way, what changes? So we know we're going to get plus or minus 4, right? But this one's original. Can I put a negative 4 there? No, I can't, right? In that current state, because it's log of a negative argument. Okay? So this one, the negative 4, doesn't work in this form when it's set up like this. In this guy, because we can't put a negative, when you put a negative 4 for x, it'd be 2 log of negative 4, and we can't have a negative argument if there's no exponent. 2, you can put the 2 back up, but in its current state, we're just saying it's not possible. Right, the starting equation to check, yeah. So you want to use your starting equation to check. Okay, so solve the equation is graphing technique. So if I want to use a graph calculator, it's fine. So why don't you put both those into your graph calculator? I'll pause the video. So you're going to put the log of x squared equals log 16, and you'll see the difference. And you're going to put 2 log x equals log 16. So if you're saying, well, what do I put in? You're putting essentially this into y1, this into y2, this into y3. You don't need to put this in again. Log 16 is the same. So you have the 3 values there you're checking. Okay, you also could put it, if you want to have just 2 so you can see it, you can put this as well. You can put log x squared minus log 16 equals 0. And you could put 2 log x minus log 16 equals 0. So these are 2 y2, y1. You can do that as well. But your picture should look, you should have a picture doing this. You should have one doing this. And then this side would just have this. So it's missing that -4 piece, is the point. Okay. Okay, let's take a look here. So yeah, when you do it the first way I said, look at log x squared turned on with the log 16, and then 2 log x turned on. Don't look at them together so you can see the difference. Okay, and if you do it the way I told you, there'll be a log 16 line here. It'll go straight across. That's the value of log 16, and that's going to be 4 and -4 intersections for that. Okay, so that's what's happening. Okay. So in reality, though, what is the issue? Like, why is there a difference? The difference is pretty simple, right? The 2 ways they're written have different domains. So when I think about the domain of this one, domain of x squared, to be positive, is everything. Everything squared is positive. So the domain of the first one, domain of log x squared, is xer. Domain of log x with a 2 in front is x greater than equal to 0. And so their domains change. That's what happened in terms of your solution change. So I think you'll do good with the solving today. I think solving is going to make sense to you. Okay, but I think the thing you have to focus on is when you're checking your solutions, kind of having an idea of what to expect in terms of why something didn't work. Okay? All right, so let's go ahead. We're on the downcline here, right in the middle. All right, so let's solve these here. Okay, so I'm going to kind of zip through these ones just so that we can get a little, see the patterns. So first off, they have the same basis, so we're happy with that. So as soon as I see that they have the same basis, that's a minus. So that means what? For if I want to put them as 1 log, division. So the first thing I would notice if I was you, you have log base 4s everywhere. This is going to be a log same base equals log same base. So now our next thing is, let's condense. This one's already good. So you're going to write log base 4, x plus 1, and 2x minus 3. The minus means the 2x minus 3 is on the bottom. This is division. Equals log base 4 of 8. Now that we can drop the logs because they're the same. So it's going to be x plus 1 over 2x minus 3 equals 8. And now we're going to solve algebra-wise from there. Okay, before I get going on the solving, any questions on that? So we use the quotient rule for logs first. Got our logs to be the same base equal to the same base. We're able to drop the logs, and now we can solve. So 2x minus 3 multiplied to both sides. Let's get rid of the fraction part. So we have x plus 1 equals 16x minus 24. I'm going to minus the x, minus the x. I'm going to add the 24, add the 24. So that's gone. That's gone. 25 equals 15x. So x is, what was that, 5 over 3? So x is 5 over 3. Let's go ahead and, we can check that. When it's written like this, it's a type of deal where you can go ahead and just plug it in, and you can put it in your calculator. Because, it's kind of hard to see 5/3 plus 1. That's 8/3, so it might be a little ugly, but you can just calculate. You can just put your calculator. Put 5/3 plus 1, 2 5/3 minus 3, and then see what that is, and then see if that's the same thing as log base 4 of 8. They beat both decimals, by the way, because 4 doesn't have an even power that gets you to 8, because 4 squared is 16, right? Okay, so now this one, what's the thing that kind of throws a wrench in everything? The 1, yeah, the 1 does. So then my next thing is, if I have a 1 or a constant, as soon as you see a constant in these solve, you're thinking log to exponent. Okay, you're thinking log to exponent. Because remember, log to exponent, we're looking for this, right? Yep. When we do that, we're going to put log to exponent. Yep. So constant, we'll just call it s. So we're going to be doing this. We're going to get in this form. And so then, as Aiden said, yes, we're going to add this log over. So it's going to be log base 6 of x plus 4 plus log base 6 of x plus 3 equals 1. And so now we can write that as one log as a product. So it's going to be log base 6 of x plus 4 times x plus 3 equals 1. And see, we are in the form I just told you. Now we're going to move to exponential, just like we started with in our first problem. So how would I write exponential-wise? 6 to the 1 equals x plus 4 times x plus 3. And now we're going to solve from there. Okay, so as you're writing, I'll just kind of keep working through. Any questions? Let me just stop for a second. We're okay? Okay, so this FOILed out would be x squared plus 7x plus 12. Then 6, so minus the 6 over. And it factors to x plus 1, x plus 6. So my solutions, -1, -6. And we have to test those now. Just kind of looking at that, which one do you think is probably not going to work? Yeah, the -6 probably, because I'm putting that in, it's probably going to give me some negatives, which it does. The -1 doesn't, right? -1 up here, that's x plus 3, so that's going to be 3 there. Okay, this right here, so it's going to be log 6 of 3 equals 1 minus log 6 of 2. And so this I would just calculate this, just see if those are equal values. Okay, if they are, then you're good. Okay, I'll pause the video, let's try that. Okay, so when you check those, we get them as they're the same values. Right when you plug in -6, you're going to get log base 6 of -2. Can't do that. You plug in the other one, you get log base 6 of -3. Can't do that. The argument can't be negative. So in that case, those -6 is saying we're saying no good, and then -1 is good. Okay. All right, I'm going to go ahead and let you guys try this one. You can try with your table partner if you have one. If you don't, just try it on your own. Once you get your answer, if you want me to check it, I'll come and check it. But go ahead and if you're watching the video, pause this and go ahead and give this one a try. And we'll see how. All right, so this is where you should be. Everybody was here. Everybody had so far, I saw log base 3 of x squared over x plus 3 equals 3. And then if we convert that to exponential, it's going to be x squared over x plus 3 equals 3 cubed. So then that's going to be x squared over x plus 3 equals 27, which you'll multiply to this, because that's going to come over. There's your 27x. So then you'll have x squared equals 27x plus 81. Move these over. This should be your quadratic. That's what you should be in quadratic formula on right there. All right, so we're having some calculator issues, so let's go ahead and put it in our calculator. Let's see if we can figure these issues out here. So we got, all right. So we got our b. So remember, it's going to be, when you put in your calculator, it's going to be 27, not -27. A lot of people mess that up. So it should be -27. I always use brackets just for the top, because if you don't, I bet you a lot of you guys messed up because you didn't use brackets. If you just put -27 plus the root and divide, it's going to divide first out the 27. That whole thing needs to be on top, so you want to bracket the whole top. Okay, so let's do the plus first. Plus square root. Okay, and then we got -27 squared. Doesn't matter. What's that? Oh yeah, this is supposed to be positive. I said that, but I didn't do it. Thanks. I thought I was talking about the square. Thanks. This one should be positive. Okay, good. All right, now we can go over. Okay, and then we got minus 4a, which is 1, c, which is 81, which is a negative 81. Okay, and I like to go and do this now. Just give this, see what it is, and then I'll divide it by 2. 29.72. So that's what they got.
When you when you just you don't put it in your calculator right away, you get the root of 1,063.
Okay.
And you can take an 81 out of that. So when I did that, I did 3,000.
Okay, I can look at that, but I mean, have it right here. But yeah, we can look at it in a second. So then, dang it, should have done it a second ago. So now we go 27 minus. Okay, I don't have to use a bracket, so I'm going to divide second, so that's fine. 27 minus square root, the negative 27 squared, minus 4 times 1 times the negative 81. So there's your two answers right there, 29.72 and negative 2.72. So when we do that, we come back to that. So we have we have x equals 29.72 and x equals negative 2.72. You can see when I put this in to this one right here, remember, way it's written now, it doesn't work, right? Where it's written now, it doesn't work because the x is negative. Okay, so this one's rejected. This one is okay. Okay, I can come look at a second here. I'll come look at you guys, show me what you in your calculator, what you got it wrong. I can come help you fix it. Yeah. Okay, so let's go here. All right, so we got the last part here. So solving more complex ones. Okay, so it's a little bit tougher. Okay, so right here, we still got to check for extraneous. Okay, this one right here, it's a log of a log, so it looks pretty difficult, but at the same time, it's not too bad because I can put 2 to the 1 equals this. So it's really not that big of a step. Do you guys see that? Because this is still a log of something. So then when I go exponential, it's going to be 2 to the 1 equals log base x of 3x plus 4. So it's not really that big of a deal, that one step there. Yeah, you can keep 3x plus 4 in brackets, is fine. And then now, we're still good. It's x squared equals 3x plus 4. So it looked insane. I just went exponential form, exponential form. So the first step, 2 to the 1 equals this whole thing. That's the exponential form. It has a log in it again. X squared equals this. We just went exponential form from log to exponential form from log. So now we're just going to minus those over and factor. X squared minus 3x minus 4 equals 0. X minus 4, x minus 1. Yes, plus 1, thank you. Thanks. Okay, plus 1. So that means 4 we're looking at, and negative 1 we're looking at. Okay, negative 1 doesn't work because we're not going to have base of negative 1. Okay, we're not going to have a base of negative 1. So that one doesn't work. 4 works. We don't in the sense of what we're doing for these. Because if you have negative bases, those aren't exponential or equations. Because if you have a negative base, it flip-flops. It goes back and forth, so it's kind of weird actually. Because every time it's going to flip from positive to negative. Okay, last page. Stay with me. Last page. Okay, solve the equation log x squared minus 3 log x equals 10 by using laws of logarithms. Okay, so this one, it looks hard, but we're going to push the 3 up. And it's going to get easy pretty quick because we're going to put division here. And we can simplify x squared over x cubed. So I'll stop there, catch up. So first thing, push the 3 up, wrote them with division, simplified them. X squared over x cubed is a 1 over x, and now I'm good to go to exponential form. How is it 1 over x? Because there's 2 on top and 3 on bottom. Okay, and so there's a couple things we can do. We could write this as x to the negative 1 if we wanted, or we can write this as 10 to the 10 equals 1 over x. Do you see our 10 to the 10? Okay, because it's log base 10. I think this is easiest to me because, do you see what we're going to do? Times the x, divide this over. You see that? These are essentially going to switch spots. So it's going to be x equals 1 over 10 to the 10, which means x equals 10 to the negative 10. That's a really small number. Okay, because when you multiply the x over, then you're going to divide the 10 to the 10 over. And so it's just going to go right underneath it again. Okay, just a little bit of math 9 that we used to talk about in terms of switching spots when you're solving. Okay, so x equals 10 to the negative 10 is the solution. Okay, and so the problem is, in terms of, like, we got x equals 1 over 10 to the 10 or 10 to the negative 10 is fine. And it says, oh, this one, this is not a law of logarithms. That's different. So when it's saying that's, sorry, B is a totally different question from what we're doing. It says, why can't that one right there be using laws of logarithms? Because see how it says the whole thing squared and not on the x? The whole thing squared is a different thing. That's actually the whole logarithm value being squared, so we can't drop that. Okay, so if you're not following me, I know some of you guys are falling off for a Monday here. This right here is different than that right there. I could drop the 2 here. I can't drop the 2 here because it's the log x value, not the x itself. Okay, so maybe the better way of saying it in terms of the terminology, if the argument is squared, we can use it. If the whole thing's squared, we can't. Okay, so that's what's wrong here. Just I'd put whole things being squared. Not part of our laws. Okay. And so then it's going to give us a little bit of a strategy to help us solve this. Okay. It's a little bit different. So we'll go through that. And this is the last problem. Okay, it's a little bit harder. It's kind of using the substitution method. Okay, so replace log x by a new variable a. So log above, if we do log x with a, that means it's going to be a squared minus 3a. Look up there. Equals 10. We are putting, wherever there's a log x, we're putting a. So up there was log x squared, a squared, and then it's minus 3 log x, so minus 3a. We're using substitution. We use this strategy with Math 20, where we took out, we saw the pattern of factoring, we subbed in a variable just to help us sort through it, and then put it back in later. That's what we're doing.
Will you know when to do this?
Yeah, I'd say whenever, that's a good question. So let's just go back. So right now when I look at this, I see something squared times, like, to me, I automatically kind of see that as x squared minus 3x minus 10. And so it's kind of holding that trinomial factoring look. And then especially Ollie with these ones, if it's a whole logarithm squared, we're going to probably want to substitute. That's kind of the tips for these ones, okay? Are we good? All right. Okay, so what it's going to be then, so we replaced it, so it's a squared minus 3a equals 10. We'll move the 10 over, and then we're going to factor. We're just going to do our normal stuff. So we do that, we're going to get a minus 5, a plus 2. Okay. And so then we get negative 2 and 5 is our answers for a. And so that means log x equals -2, and 5. That's what a equals, right? And so what we're going to do is we're going to see what does that mean. So what does this mean? X equals right? 10 to the -2. So it's 1 over 100. It's 100th is the answer for the first one. This one, oops, not log. X equals 10 to the 5th. We plug those both in, they both will work. Okay, I'll save us a little time. When you plug them both in, you plug them back up to the original, it's going to work for both of them. Okay, so remember, this is 1 over 100, and this is 10,000. Oh, no, 100,000. It's 5 zeros. Okay. All right, and then D, a student solving a logarithmic equation similar. Okay. So let's look through this one. So student solving equations, so this is the same one we just had basically because the 3's pushed up, right? And she did it this way, log x squared minus log x cubed. What's wrong with this? What's that? Yeah, this right here is not correct. You can't do that because it's not, the whole thing's not cubed, just the x's. Okay, so that's essentially the error. Okay, let's go ahead and find the, well, if we do the correct one, guys, this is going to be the problem we just did, so we don't have to do the correct one. We'll stop there.